In the in this tutorial, we are going to look at how to solve Fibonacci. That is, we take input from the user about the nth Fibonacci value that they want to calculate. So, and with that number, we'll calculate the Fibonacci using recursion and return it to the user. This first part of the video, the first video would include just the recursion, and the second will include memoization as well. So look out for that as well. Memoization will reduce the number of iterations you have to go through. It will reduce the number of uh, recursion that you have to perform, improving the performance of your code. So let's begin with the code now. So here's the code, and I'm writing a function. Uh, it's a recursive function. It will take in num as input. Okay, and let's begin. So to start with, I need to put some uh, value here, right? So the condition, right? Like previously explained, what a Fibonacci value is 1, 1. Addition, it starts with these two numbers, and then addition of these two numbers is the next number. So the third Fibonacci is 2. The fourth Fibonacci is 2 plus 3, which is 3. 2 plus 1, which is 3. Fifth Fibonacci is 3 plus 2, which is 5. 8, 13, 21, and so on, right? So we need to calculate this, okay? So if the user says, get me the third Fibonacci, we have to return 3, okay? So what we'll do is we'll go from here, okay? Uh, addition of previous two Fibonacci numbers, right? Simply 1 plus 1 is 2. Addition of Fibonacci of 2 and 1 is 3. Fibonacci of 3 and 2 is 5, right? So all we'll be doing is calculating Fibonacci of previous and previous to previous and add them to get the next Fibonacci, right? So for example, if I'm calling with an example recursion, I call say fifth. I want to get the fifth Fibonacci. So what will I do? Okay, first of all, where should my function stop recursing? It should stop recursing at when num is less than 3, right? Because 1 and 2 and 3, right? So third position I'll still calculate, but for the first two, it's going to be 1 and 1 only. So every time I get 1 or 2, it will be returning 1 only, right? Now my function to go deeper into the recursion. So if I have to go deeper into recursion, I'll call the same function, and this time I'll subtract num minus 1 I'll subtract 1 from num and pass on. Plus I need to add another recursion for Fibonacci, which is num minus 2. So whatever I get uh, return from this function, I'll be adding these two. So this will return me Fibonacci of num minus 2. This will give me Fibonacci of num minus 1, and I'll add it and I'll return it, right? So that is simply my code, and let's try that out. So the fifth Fibonacci is 5. Let's try with the fourth one. It should give me 3. The fourth Fibonacci is 3. Let's try the sixth one. It should give me 8. The sixth Fibonacci is 8, right? Let's try a bigger number, say 25. believe it will take a lot of time to get me 25. Let's try to get 33. Right, you can already see it's taking so much time to get me that. As the time has increased, let's go with 35. It will take even more time to calculate for 35, and that's an issue. So although we have successfully booked around a function that will calculate Fibonacci, the issue remains that for slightly big number beyond 35, it starts taking a lot of time, exponential time. So if you put in 50, your program will crash, your CPU will not be able to perform that big calculation because it's recursive. That many functions are left open, right? So to get resolve this, we are going to use memoization. Okay, memoization is something that we'll be discussing in the next video. See you there.